Hey everyone,
Perfect.
thank you for joining us today for our Dorsey Power Hour series. My name is Blake Bonham, the sales engineer out of Spokane, Washington, joined by our other Seattle sales engineer, Scott Boucher. A couple of other guys are out for trainings, Chris and Nick, but this will be recorded, so they'll tune in to this later. Today we will be talking about our new custom air handler line, Ingenia. And here to discuss the applications and features from Ingenia Technologies is George Mastro Monaco. Hopefully, I got that right, George.
You
He's
did
the
it. It's a
VP.
tough one.
It's a tough one. He's the VP of Sales and Marketing. He's been there since day one. They've been there for how long? 23 years now, George. Pretty
23 years,
impressive.
correct. Yes.
And so he's going to do a little presentation, product overview, applications, and whatnot. A couple housekeeping duties. Everyone's muted, but if you have a question, please enter it into the chat and we can answer it in real time. And then we'll do some Q&A at the end. But yeah, thanks everyone for tuning in for the Power Hour series today. And George, I'm going to hand it over to you, and I'm excited to learn. So thank you, George.
Perfect. Thank you so much. Good afternoon, everyone. I'd like to get started with giving you a quick overview of the company for those of you that are not familiar. So, Ingenia Technologies, uh, basically, we started the business 23 years ago, private company right up to February 2024. February 2024, the company was acquired by SPX Technologies. SPX has its headquarters located in Charlotte, North Carolina. So we went from being a private company to now being part of a very, very successful large business, very focused on quality products. This specific slide is showing a little bit of the main products on water side and air side. So if you're familiar with Straubing fans, Marley cooling towers, Tamco dampers, Cincinnati fans, they're all part of the SPX family of products. And Ingenia Customer Handlers is basically a customer handling line. We also have many products related to heating, gas and electric heating, Weil McLean, Patterson Kelly, and on the electrical heating products, you're probably very familiar with Indico and Brash. Those are all part of our family of products. I will be just focusing on Ingenia. So Ingenia is headquartered at the moment in Mirabel, Canada, Quebec, Canada. So on the eastern part of Canada, we will be opening a plant in the Alabama region in mid 2026, just to supplement our production capabilities. So Ingenia from day one, what we focused on is technology, both on the design side, upfront process, and manufacturing. The technology is completely integrated with designer handlers, with our System One software, and practically download, manufacturing files directly to the plant. So we really focused on first of all, ensuring that the customer experience is flawless from beginning to end. Advanced technical digital manufacturing technologies, very, very important to the process because we wanted to build a product that has the finest features, which I'll show you in a second. The plant in Mirabel at the moment is 300,000 square feet. We've gone through 5 expansions, and the latest one took us to a space of 300,000 square feet. All of the manufacturing processes are completely automated. The sheet metal lines, basically, we start from raw material from the mills, and all of the punching, shearing, and bending occurs automatically through the process. For example, even gaskets are applied robotically, liquid urethane, in this case, being applied to filter gaskets. All of the heavy gauge bending and handled by robotics also here on the right-hand side. The assembly of our panel systems, which I'll describe to you in a few moments here. They are very unique. They have a complete no-through metal system. And the reason for that is to eliminate conductivity through the wall, eliminate heat transfer through the wall. Our base insulation is injected polyurethane. R value 6.5 per inch, and obviously that offers the highest possible R value, but also renders extreme rigidity to the panel system. We also manufacture our AHRI certified heat transfer coils in-house. If the product requires painting, then we have an in-house electrostatic powder coating system. Many advantages to electrostatic powder coating. One of the basic ones is the resistance to the salt spray test, which is 10,000 hours versus the typical enamel, which is anywhere from 500 to 1,000 hours, so highly resistant. The same product is available with an antimicrobial component, which is really used in the healthcare type of facilities. So in those cases, we powder coat the entire interior with the antimicrobial sterile coat system. So looking at the applications and the customer base, 80% of our business is in life sciences, labs, hospitals, pharmaceuticals, biotech, and universities. That's the majority of our business. Now, the product is custom and can be easily applied to many other industries. We've got a lot of customers in the museums, art galleries, and even clean rooms and electronics and food processing. There's a specialty product that's being developed for data centers, and that's why it's at the bottom of the list. It's actually a developing type of process or product. So this is, Ingenia in a brief summary. Now I'd like to switch to the construction features and tell you a little bit more about how the product is built, which is extremely unique. And then I'll also tie it in to the selection software, which is entirely, automated. So looking at the construction features, first and foremost, we have a cabinet design that has a very unique seal method. The seal consists of a triple seal, actually, a bit of caulking, membrane, a rigid membrane, rigid plate, and bolted onto the cabinet, which is very, very important to ensure that the air leakage rate is practically close to zero at pressures up to 15 inches of static for 4-inch walls. The clad roofing system for outer units, we build an external clad roofing system, which is completely independent from the pressure seals of the units. So weatherproofing, pressure seals, entirely independent. So the idea is to build a product that's completely flexible in design. There are no limitations. There are no increments. We practically can design any geometry that's needed, but also having a superior finish, of course, ensuring the best possible end user comfort and simplified maintenance, looking at every aspect of the unit and ensuring that it's easily accessible for maintenance purposes. So let's take a look a little bit closer up to the construction of the air handlers. So very uniquely, as you can see here, we have a complete no-through metal system between the exterior panel and the interior panel. So it's basically built in two halves. In between, we have a rigid separation made up of high-density polyethylene. So it's a plastic polymer. And the idea is there is to disconnect entirely the metal-to-metal contact. As I was saying, the insulation is injected foam, and the injected foam is actually for the roof panels, wall panels, and even floor panels. So floor panels, as you can see from here, they actually also have a complete no-through metal break to ensure that the thermal properties of the floor are consistent. And in fact, we separate the floor system, the thermal resistance of the floor from the structural framing of the unit, not to interrupt the thermal properties. Here we see some other details. So the floor sections and the floor perimeters are slanted to allow, if washdown is required, water can easily be collected in every section. The section here, or the detail here, is actually showing the no-through metal component consistently throughout the floor and the wall. This section here, we see the different floor segments that are welded to each other. The checkered material is actually used only on the walkable areas. Non-walkable areas have solid finishes to ensure that we have proper mating of different parts and minimize any leakage. Once again, here we see the neutral metal component of the floor system, and we also see the floors on the right-hand side. In a little bit more detail here, you once again see a panel system and how that panel is built in two halves that's joined together with this bolting system that connects to the high-density polyethylene. And the assembly of the panels to panels is actually with rib nuts. We do not use any self-tapping screws. So in our design and estimation of the product, it is beneficial to use a bolting system that it's much more resistant to the longevity of the product that we design. A little more detail here. I talked about the seals previously. Here we see the wall panel assembled to the base. And the triple seal is once again a bit of caulking, rigid membrane, and a rigid plate on top. So it's a triple seal over every single joint. And the rigid plate is bolted on to the floor, to the wall panel system in this case. So whatever we are assembling components, it is a bolted process, which lends itself to be extremely valuable for the end user because obviously the resistance to, again, to the life of the product is much, much better, but it also makes the assembly easier. So if you're thinking of knockdown projects, assembly is now bolted systems rather than the old self-tapping screws. I mentioned briefly at the beginning, in outdoor units, we separate the cladding roofing from the pressure seals to ensure that there's no interaction between both of them. So the pressure seals and thermal properties are uniform. And on top of that, we have a clad system that can be designed, obviously, in any direction that's needed. On the right-hand side, we see a bigger handler up against a wall. And so in that case, the sloping is towards the one side only. And here in the middle, we see one section of a big unit with sloping to one side and the other to the other side. There's additional views here. So this is extremely important. And, most manufacturers will have a single roof sloped in different directions and sealed with lots of caulking. We try to avoid the use of caulking to provide air, seals. And the assembly is completely bolted. So easy to put together in the field or at the factory. I'll talk just a little bit about the filters and filter racks. We use aluminum extrusion filter racks for rigidity and cleanliness. So the racks are again bolted with rib nuts and bolting systems, providing a very rigid assembly. In this case, they're HEPA filters. In the case of regular high efficiency or pre-filters, they are individual racks, again, built of aluminum extrusions. The assembly of the filters or the holders to the frame is actually made up of clips rather than aluminum or their galvanized steel sections. All of the doors have, as a standard, dual gaskets with a complete no-through metal brake. So the R value and the thermal properties are consistent throughout the cabinet of the air handler. In fact, even if there are test ports, they have a no-through metal system. Hinges are milled at Ingenia, entirely fabricated here. And the reason for that is to ensure the precision manufacturing consistent with the product. All of the doors are also designed and built at Ingenia with, as you can see, multiple layers of seals to provide the rigidity and resistance that we need to meet the static pressure requirements and leakage rates. Inspection windows, once again, many layers to make up a rigid and basically leak-proof type of inspection window. The entire assembly is bolted. So in the customer handling industry, or some manufacturers will stack coils one on top of the other. We actually design them with individual cooling coil racks so that you can remove each coil individually. The length of the drain pan will vary as a function of the air volume, phase velocity, and fins per inch. So this is completely variable, adapted to each project. The seals, the pipe seals, are with rubber grommets, um, very carefully and precisely installed. So let's look at the performance of the cabinet. So we have three wall thicknesses, 2, 3, and 4-inch thick, anywhere from R13 to R26, depending on the thickness of the wall. The leakage rates are significantly less than 0.5%, 10 inches to a maximum of 10 for 2-inch walls, 12 for 3-inch walls, and 15 for 4-inch walls. And the deflection rate, less than 1/240. So we can, for tests are conducted at the factory as required for the projects, and also as part of our quality control system. So all of our CFD, if required for the projects, are done in-house. In this case, it's a simple CFD to show the thermal performance of our panels compared to the typical industry, standard 4-inch walls with fiberglass at the bottom versus our 2-inch foam panel up on the top with a no-through metal. As you can see, the consistency and uniformity of the temperature. And that's the objective. Now, it is not 100%. The approach or the performance of our joint is probably in the range of about 95 to 96%. So there's a little bit of a loss, but very minor. Significantly better than traditional panel systems without a no-through metal component. I talked previously about the powder coating, very beneficial specifically to the healthcare market, pharmaceuticals, biotechs. The majority of our customers are specified antimicrobial coatings on the interior. It is surface protection, not airborne protection against antimicrobial components. Again, if you look at a finished air handler on the interior, this is one where the entire inside is powder coated. In this case, there are in addition to the foam injected floors, there are additional acoustical panels installed on the interior. We factory install controls, frequency drives, completely flexible as to the specific needs of the projects. We also manufacture sound attenuators. They are rated by an independent lab, and they'll be designed for the specific needs of the air handler in terms of height, width, and length of the baffles. In this case, they're also powder coated with an antimicrobial component. Acoustically, we modeled the air handler. I'll show you in a second the software program. And after designing the air handlers, we also modeled the sound. So we know the sound power level of the intake, discharge, and radiated. And to achieve the results that are as required by the projects, there are different methods that we can use. One of them is using acoustical baffles within the air handler. Coils are manufactured in-house. Let's talk for a second about configuration. So we can ship our handlers in one piece, in multiple sections, or completely knocked down. So the benefit of our knockdown system is that it's entirely bolted. So we don't simply design the air handler and ship it knockdown. We actually engineer the product. So from the very beginning, we work closely with the engineers and contractors and sales representatives to ensure that all of the parts that need to be brought to the mechanical room can make it through the available space. So there are no limitations as to how we can, break down the air handler. So for the retrofit market, there's a big advantage of this bolted system versus the traditional sheet metal screw method, where the feedback we have is that it takes 50% less time to assemble our units versus competitors' air handlers. So we very carefully palletized in the case of knockdown air handlers in all their parts very carefully. Each part is barcoded both with a label, and also the part number is laser printed on every single part to ensure that it's there for the life of the product. We also send dynamic electronic files that allow basically the end user, the contractor, and the engineer actually to carefully review the product. The contractors will, of course, benefit from this here because they can easily relate to all the parts. In fact, I'll show that right away here. I'll open up a file. So this is one file that I simply opened at random. And so these electronic files, again, I picked a project at random here, Pittsburgh University West Scafee Hall. This unit was shipped actually to be field assembled. So you can look at different components. You can actually even get any details you need as focus on specific areas. And the idea there is to provide as much detail as possible to the contractor. And again, the owner has these files for the life of the unit. These files are actually outputs from SolidWorks, and you don't need to actually have the SolidWorks software. It's a simple viewer that can be downloaded free of charge. Of course, the contractor also focuses on individual sections. So I'll open one right here. So in this particular, this is module number 1, and parts are easily identifiable by bringing your cursor close to the parts or to the bill of material, and basically see how the part number relates to the specific parts of the unit. Again, if for knockdown air handlers, it's no longer just a simple stack of paper. It's actually an electronic file that guides the process from beginning to end. Each panel is entirely insulated. There is no need for field insulation. Every part is entirely made with the rib nuts pre-installed. So with this guided process, it makes it very easy to field assemble air handlers. And of course, this ties in very closely to the selection software, which I'll show you. I'm just showing a completed unit. But so in designing air handlers, as I was saying, it's completely flexible. As you design the air handler, you generate a complete model of the unit, and very very simply pre-assembled or pre-engineered sections are grouped together. You start from a simple, CFM air volume, and then the guided process takes you through the design of the unit, the selection of the components, and every other aspect of the unit. So this software links directly the design to the manufacturing of the parts in the plant. So it's a very, very complete and precise process. Submittals are generated directly from here as well. So we'll get back to this in a second. I'll go back to the PowerPoint. So as I was saying, so these are the files that get generated for every single unit, whether they're shipped in one piece, in modules, or in sections. This is, we refer to units such as this shipping in one piece as modular air handlers. They're higher quality modular air handlers in the sense that you can have drain connections in every section. The units can be washed down. They still have the properties of a complete no-through metal wall construction. So if you're designing lower temperature air handlers, the R values are high and will provide you the condensation-free, design on the panel systems. And the the same software is used to generate completely custom air handlers where you can have dual tunnels, you can have with a common vestibule or triple stacked air handlers. I mean, complete flexibility of the design. So this is very unique in the sense that most of the time, most manufacturers will have a guided process where you have the design completely separated from manufacturing, from purchasing. Um, our software actually links the entire business process from the design to the shipping. In fact, the ERP is directly linked to the software, and the pricing is live. It is based on actual prices on the specific day. So now I'm talking a little bit about fan arrays. So we can design fan arrays with, on the right-hand side, we call them heavy-duty fans, Twin City or Green Hack. Both of them are very good supplier of ours. On the left-hand side, we see EC fans or fans with EC motors. In this case, they're Zillabag. We have multiple suppliers for EC motors. We also develop and design our own control panel system so that you can monitor individual airflow, totalizing airflow, communicate directly with the BMS, power panels, and on fan arrays, there's no limit as to the number of fans that can be designed in the units, and multiple options for AC motors or EC motors. So the question often comes up is, well, how many fans is the ideal number of fans? There are multiple answers to that question. Our logic is use the least number of fans to achieve the objective. And here there's an example, with these are traditional fans with AC motors, and we go from 1 to 9 fans. And you can see, again, right from the selection software, the total brake horsepower, goes from 30 HP to 34. So one fan is more efficient than multiple fans. However, there are other advantages, for example, sound. Sound can be, reduced significantly from 93 to 79 by using smaller fans. But again, that has to be looked at carefully. Now, if the objective is to minimize the weight of the motors, and let's say they have to be 10 HP maximum, then obviously we'll design according to that parameter. But using the least number of fans, is usually what makes the most sense. 4 fans will typically give you complete redundancy. If one fails, the other 3 can make up the difference easily. Here, there's examples with fan arrays. Again, on the left-hand side is a typical fan array with AC motors mounted on seismic isolators. In this case, also the interior, so you can see, is powder coated with an antimicrobial coating for healthcare type of applications. On the right-hand side, this pertains to AC motors. And what the idea here is that the larger AC motors hold their efficiency much more as you decrease the loading of the motor, while smaller motors lose their efficiency or decrease in efficiency more rapidly as you get lower than 60%. So For that idea, once again, it is best to use the biggest possible AC motors. And just by design, as you know, AC motors are obviously the bigger motors are much more efficient than smaller motors. So once again, keeping the highest possible motor for the application. In terms of this is some information that we provide. Some people ask about the relative cost of single fans versus multiple fans, and obviously the cost is higher. A single fan for this particular case, again, is 120,000, and as you go to 8 fans, you almost double the price of the section, not the entire air handler. This is just a fan section. But there are advantages. For example, the section length can be decreased from 190 inches to 160. So, and then you got to look carefully also at the MCA and MOP. There may be advantages of using, single fans, but that's not always the case. The MOP actually is lower with the 8 fan arrangement. So there's multiple factors that can lead to, the use of fan arrays and multiple fans. And if the units require the use of monitoring airflow, the control panels are designed here. They are programmed here. So one thing I did not mention about Ingenia is that out of the 240 employees, basically 10% of the staff is actually made up of programmers, so that all of the automation in the plant, all of the HVAC programming and software is all completely developed in-house. So we are in terms of motors again, we're using a lot of different the newer trends in the industry. We've tested extensively infinitum motors, great performance, a little better than conventional EC. So there are advantages to using this motor, lighter, less weight. So in terms of sustainable designs, very good product. And but we are using again a multitude of different motors. For example, ABB EC titanium motors are also used in some applications, again depending on the customer base. And I'll just touch on again CFD analysis. If you are working on projects that would require the need for CFD, it is done in-house. Our R&D department definitely can embark on any CFD project that's required, and they can provide CFDs that are specific to airflow, static pressure, thermal properties, all done in-house. So those are the construction details of the units. What I'll do is show a couple of other designs here. So before showing just like a brief glimpse of the software program and the functionality of it, this is another example of a triple type of rooftop air handler with double vestibules, one on one side, one on the other. Perhaps we see it better if we do this. So sometimes, we've seen it in many designs where, the owner would rather see, multiple rooftop units within one enclosure. This is one case where the air handler was shipped in 15 modules. And so what we did is have the vestibules and all the electrical mounted in the vestibules, and also providing all of the pipe chases required so that when the piping gets done in the field, they can easily bring it down into the building. So that's, and there's also a space for a mechanical room at the end of the unit. So lots of flexibility. And in fact, the interstitial space underneath the roof, I'll just show the roof here for a second. So this is the enclosure. When we look at the inside, portion of the interstitial space at the top was for the return, and the other section for the outside air. So outside air travels in that space and goes back into the unit. So lots of different, very different designs are available. Uh, so I'm gonna just close this one here. So
Hey
what
George,
I'll
that was for a university job. Is that what I was seeing?
so that was for West Virginia University, correct? Yep, that's
Okay.
West. Um, what I'd like to do is show you a little bit of the software. Oops, sorry. Just set this up really quickly. Yeah. Yeah, so that was a university project, West Virginia University. And so what I'll do is I'll just take a few minutes. I'm not going to go through all the details, but I'll just show you some of the flexibility of designing with this type of software, which again gives you complete flexibility. You're seeing the project management phase. I'm going to go into creating a new custom unit. So rooftop, indoor, uh, one piece, multiple pieces, and oops, let me move this to the other side. Second. Switch over, switch screens here. Okay. So now we're back on the screen right here. Yeah, so as I was saying, indoor and outdoor. So I'll just start for something very simple. I'll just call this here issue 19, and we select the facility type. Let's say hospital, 25,000 CFM. And so what the program does is, first of all, tells you, okay, for 25,000 CFM, the ideal height and width is 95 and 1/8 by 124 and 3/4. And you can accept that, or you can say, well, that height is a little too high. I can't exceed 90 inches. So you simply input 90 inches and you recompute. Obviously, the width will get a little wider. And this is based on 450 feet per minute. Of course, you can set that to whatever you like, 500 or 400 feet per minute. Right now, the default is 450. On the right-hand side, it gives you a very quick summary as to the performance you can expect. So from the front-loading filters, 417, cooling coils, 451. So that's pretty close to my 450. So I'm going to simply accept that, and then I simply go to the sections. And if I'm building a simple, air handler with starting with a mixing box, simply select. And first of all, I'll simply go here and keep on selecting. Let's see, I'll take a filter section, a heating coil section. I'm doing something simple, right? Just to show the easiness of custom air handlers nowadays. It used to be years ago that you would, spend a lot of time and would have to go through CAD operators to generate options. Nowadays, actually, it's just going to the software, and sales engineers have everything they need at their fingertips. Uh, if I go into a fan section, uh, I'll just select this one here. And from that basic configuration, now I can simply go into the other screen, which takes me to a little bit more detail. I can open that up and see how that looks. And from there, I can obviously go into the material tab, for example, go into the unit and go into the materials and select different materials. The standard insulation is polyurethane. I can override materials and, if I wanted to change the external liner from galvanized to embossed aluminum, I can do so and I can apply. Basically, if to the program defaulted to standard thicknesses, but I can alter them as I need. Now, for example, the fan section, what I'll do is I'll go here, and the one thing that I want to do is we don't need that door in the fan section, so I'll simply go and say no door. Remove that section. Now I can go to that specific section and say, okay, go to the fan kit. And let's say this is a fan array where I decided that I want to use 4 fans. Simply do that. Of course, one of the things I'm missing here is for the simple unit is a discharge plenum. So I go through the gallery 3D and go into the discharge plenums. And of course, I have a lot of different options. I'll just pick one. These are starting options. So we pre-engineer sections, but you can take those sections and actually redesign them and redefine them as you want. It's just a way to accelerate the design process. So this unit, I can easily go into the fan section now, the fan kit. So I can decide how big the fan cubes. The fan cubes are where the fans are installed, and they can be acoustically designed to the reuse sound, or they can be solid lined to make them wash down if necessary. And I can also decide how big I want those cubes to be. I'm just going to select a micro size, so it makes them as small as possible and keeps the distances from from the walls to the fan as small as possible. Now from there, I can go once again to the fan kit, lower, and go and can go to the selection interface. I'm gonna make another change here. I'll use green height fans. I'm gonna apply. Go to the fan selection. So this is really rendering custom units. I mean, to the point that are as easy to select as commercial units, except that you have all the high quality features of a custom unit. So right now I'm into the interface of the green height program to select green height fans. So I'm just going to say for this particular case, 6 inches of static. And I'm going to say, let's do a search. So it's giving me some options. And obviously there are many reasons why I may want to select one versus the other. I'm not going to go into the fan selection criteria, but let's say I want to select the smallest one. I want to look at the fan curb and see, well, it's right in the middle of the curb. I'm going to attach the files. Obviously, that's fine. That's part of the attachments. I'm going to be generating the submittals in a second. So I'm going to be okay with this once again. And I'm going to say, I'll select those fans. So the 20-inch diameter fans. And it says, do you want to generate? The CAPS file is actually a file generated by the Greenhide program. So at this point, it's been populated. I have 10 HP motors, and I have the blower size 20. Lots of other options. I can go through here and select options that I may want to select for the motors, the base, the isolators, and so on. Not gonna go into all of that. I can, what I'll do is I'll do a quick save here. Okay. I'll do a quick save. And so the other element that we can easily do here is generate the layouts we want to show with our submittal drawing. So we go to the standard view and we select the typical plan view and uh, elevation view, overall dimensions, module dimensions, and we'll say apply. So we've got our drawings done. The other thing we want to add is actually the description of everything we've selected. So here we go. Now we can keep adding as many layouts as you want to add for the project. Standard views, let's select a 3D view here to give it a little bit more life. Selected our 3D view. So now we'll do a quick complete save. We're not going to recalculate the weight. So the idea here is to be able to generate very precise information. Now keep in mind everything I'm doing here is actually generating all the coding I need to actually build this unit. So I can, in fact, I'll show you that in a second. Show you the submittals. I'm not going to worry about some of the little details, so I can go here and say, so all the components that are shown on the unit, of course, can be altered, relocated, dampers can be moved up and down, doors can be resized, anything can be done. The idea is to generate this package really promptly to be able to to communicate the information rapidly. So we can also export to a 2D WG or to a Revit file if you wanted to do Revit. So we'll simply go do this here, export to a Revit file, export this information. So while the Revit server is actually working, I can, as I was saying, I have to give it a second here. I can take that damper, and as you can see, we have the axis here. And if I wanted to move that damper up, I can move it, let's say 12 inches. It's very little limit as to the things that I can do. If this door happens to be in a location which is in conflict with, I don't know, a column or something, we can go to the position of that door. And once again, you're looking at the axis here. Again, there's no, in the x-axis, I can move it, whatever, 11.257. Just relocate the door, the sizing of the door. If for some reason, again, issues with the height, we can make it shorter if that's the case. So this, you can alter this in any shape and form. If so, as we're doing this here, let's take a look at the product file. So the Revit is actually ready here. We can should be able to preview it. So we wanted to render customizing as easy as possible, and being able to provide information and again complete flexibility while you're you were keeping the essential features, very low leakage. Again, leakage is 50,000 CFM units, less than 0.5 would be 250 CFM. not unusual for us to get in situations where the leakage is actually 0.1%. Again, we welcome factory visits, seeing the entire process, manufacturing, meeting the people, extremely valuable. Um, so the Revit file is a simplified Revit file showing all the interactions with the externals, piping connections, door opening, sizes and dimensions. That's easily done. So again, customizing and the idea here is the entire system. Oh, what I wanted to show you also is the control build. So if this unit was approved for, manufacturing, it's simply take it to another level, which is the building level, and this completes all of the programs needed to actually build this unit. On the bottom left-hand corner, you see the activities that are going on behind the scenes to actually create all the programs. I want to reiterate once again, knockdown units, because of the bolted construction, makes it extremely easy to assemble in the field. Assembly time is 50% less time than the majority of our competitors' products. Every panel is completely assembled. There's no need to field insulate panels. Every single bolt, whatever there's a bolt, there's a rib nut pre-installed at the factory. So again, this shows. Let me go to this view right here. So this is the manufacturing files that are pretty much ready to be sent to the factory. So that's how easy it is to actually work with high quality custom units nowadays with the newer technologies that integrate the entire process from design right up to manufacturing, purchasing. It's all integrated into one complete file. So with that, I'm not sure if there are any questions.
Well, George, there's no questions in there yet. We'll give it a few minutes in case anyone has
Sure.
anything. Uh, I guess my question is, the unit we just built, that was super cool. How long is like a typical lead time for something like that? 25,000 CFM.
So a unit like that, the lead time is about 12 to 14 weeks.
Hmm.
Yeah.
Okay.
Nowadays. So lead times are a little bit longer than we would want them to be. Uh, just factory loading. This is why, for that reason, we are expanding capacity here, and we're also expanding capacity through an additional plant in the U.S. So lots of activity going on to limit and reduce lead time as much as possible.
Hmm.
But yeah, the entire process is actually, the submittal. I know that sometimes when we talk about lead time, we're always focusing on the manufacturing lead time, but the entire process or the business process lead time is very fast because of the ability to produce information like this, submittals really quickly, designs extremely quickly. Um, Again, complete flexibility.
So are you seeing any industry trends about, the requests that you're getting for new units and whatnot, not necessarily with, your own technology, but what customers are asking for?
And so that's yes, that is a very good question. What we are seeing that's really interesting. I mean, owners are more involved than I've seen in the past. So very concerned about the quality, longevity of products. I'm seeing more and more. Again, we have factory visits every week, and owners are very involved with the product qualities, very concerned about the longevity. I mean, our units are designed really for 50 years. And they're also very competitive in price. So you no longer have to, in the old days, custom air handlers were extremely, like more expensive than basic products. Nowadays, doesn't have to be the case when you're using, good manufacturing technology. So yeah, the trend is a little bit more concerned with quality, and obviously price is always an issue as well.
Well, George, thank you for doing this presentation. That was amazing. Glad we got that on recording. You threw a lot at us, but we can go back and check it out again. If anyone wants us to do another presentation individually, we can do that to your individual firm. Like he said, we like taking people up to the factory. So if you're interested in that, we could bring you guys on up there to see this in real time. Um, yeah, we got no other questions. So thank you again, George, for providing this training, and thank you for everyone for joining us today for our Power Hour. Next week we have another one on our laboratory valves AccuTrol. So if you want to tune in next week, that is all we have for you. I'll stick around for another minute just in case there's any other questions. But thanks
Perfect.
again, guys, for joining us. George, thank you.
Thank you. Thank you, everyone. Bye-bye.
See you guys.
Yeah, hey George, I've got one more. You mentioned a motor that I wasn't familiar with.
Infinitum. Infinitum.
So that is that the manufacturer?
That is the manufacturer, correct. So that's a motor that has been introduced to the market probably about 3, 4 years ago. So we've gone through extensive testing, very good quality motors. They, the efficiency is a little higher, obviously higher than AC, but also higher than EC, conventional EC motors. They also retain their efficiency a little more as you decrease the loading of the motor. So it is a motor that's available with our units as well nowadays.
So is it like an IE6 or I mean, are you familiar with the IE? You're familiar with IE standards of motors.
I'll show you, I'll introduce this here. It's a very different motor than even, here, let me switch, let me bring over the screen here. Okay, there we're back to that motor. So this is it's an air, they call it an air core EC motor. So you see that the rotor is actually a disc. And it's also based, it's a printed circuit board basically. And also with, there's the frequency drive, let's call it a frequency drive, that speed modulation is built into the motor, right? And permanent magnets, right? So that makes it, technology is very similar to EC, for the exception of the printed circuit board rotor. And also the advantage is that you can replace if let's say the electronics fails, you can replace it individually. Don't have to really change the entire fan, which is unique. With typical EC motors, you have to replace the fan and the motor. So this is an interesting feature. Also lighter in weight, a lighter construction. So it's a very interesting, we're seeing a little bit more demand. It is a little more expensive than conventional EC, but not not prohibitively.
So does it have same kind of torque as a regular induction motor?
Yes, torque characteristics are similar, not the same, but yes, very, very practical for our variable load application. If you look at the curve here, this really exemplifies a little bit the advantages, right? At the very top is the infinitum. The middle curve is, EC, leading EC motors, and then you have the AC, right? So as you get to the 100% loading, actually, the 90 to 100%, the efficiencies are very close to one another. The advantages are the part load, right? And all in this region. You retain that efficiency.
Yeah, I have not heard of those before.
Yeah, keep it in mind because I think you're going to be seeing this a little bit more in a lot of applications. Hmm. Yeah.
That is all I had. Scott, any more questions?
No, that's it. Looking forward to more detailed presentations and getting into it here shortly, I hope.
Yeah.
Very good. Thank you, Scott. Thank you,
Okay.
Blake. Thank you, everyone.
Yeah.